So the goals that I want you to learn in this section are how to find the derivative of exponential and logarithmic functions and how to use logarithmic differentiation to determine the derivative of a function. So we are going to do this a little differently than the book does it. I like to start with the log. They start with the exponential, but we all end up in the same place. Okay, so we're going to define the natural logarithm first. Okay, why are you not, what, oh, sorry guys. Okay, so the natural logarithm function so this function is defined to be the natural log of x is defined to be the integral from 1 to x of 1 over t dt. So what does that mean physically? Physically, it is the area under the curve of the function 1 over x, 1 over t. So let's draw the function 1 over t. So 1 over t looks like this. Okay. And so we want to start at 1 and then go up to some value t. So if I take and compute, that's the area. So I can draw the area under this curve. And that by definition, if I pick an x to go up to whatever x I choose, so if I choose to go up to this x, the area under the curve from 1 to x is what we define to be the logarithm function. So clearly at at 1, the logarithm function is actually just 0. So the logarithm function does like this, and it just grows. So this is f of x is equal to the natural log of x. So it is just to calculate the area under the curve up to some value of x. That's the definition of the function. So very simple things you should know. The natural log of 1 says compute the integral from 1 to 1 of 1 over t dt, and you know that when the limits of integration are the same, you just get 0. So therefore, the natural log of 1 is 0. Okay, now we're going to use the fundamental theorem of calculus to define the derivative of this function. All right, now you guys know that you can put into your calculator, if I take and put into my calculator the natural log of 2, when I put that into my calculator, that is just going to give me a number. If I can get this right.
You said log of 2?
Yep. Natural log of 2 is 0.693147,181, and it keeps going. So I can take the natural log of any positive number. All right, so here x has to be positive. Well, x has to be greater than, x has to be positive. Okay, so I can take the natural log of x as long as x is positive. All right, so now I can do that for any number. Find the logarithm as long as x is positive. All right, let's look at the derivative of this function. So the derivative of the natural log of x, I need a fundamental theorem of calculus to help me get there. So I'm going to use the derivative with respect to x of the natural log of x. That says take the derivative with respect to x of the integral from 1 to x of 1 over t dt. And I don't know if you remember how to use the fundamental theorem of calculus, but the fundamental theorem of calculus says that whenever I take the derivative with respect to x of an integral going to x, I just get the thing inside evaluated at x. So in other words, the derivative with respect to x of the integral from a to x of a function f of t dt is just f of x. That's the fundamental theorem of calculus right there. So that's what I used. So now I know the derivative. So now I have two things. The first thing I know, so I have given y equal to the natural log of x, then its derivative dy dx is just 1 over x. All right. So that's another very important piece of information we're going to need. So now we know how to take the derivative of this function. All right, well, let's suppose it's a function of a function. All right, so now suppose I have y is equal to the natural log of u of x. Okay, well, now I need to use the chain rule. All right, so for the chain rule, I have y is equal to the natural log of u, and u is some function of x. So in order for me to find dy dx, I have to take dy du times du dx. Now, what is the derivative? We already know that the derivative of the log of x is 1 over x. So let's just extrapolate a little bit. And that would mean that the derivative with respect to u of the log of u is just 1 over u. So this thing right here just becomes 1 over u. And then this is still du dx. So there we have it. That the derivative with respect to x of the log of u of x says do the same thing. Throw u to the basement. And then multiply by its derivative. Okay. So we can do some quick examples. First one is easy. So we want to find dy dx. First one is easy. Y is equal to the natural log of x, then dy dx. One over x. That's our definition. Number two, y is equal to the natural log of 4x. Okay, so the rule says take and throw the 4x to the denominator. So we throw u to the denominator, so we're going to get 1 over 4x. Then we have to multiply by the derivative of 4x, and that's just 4. Oh my goodness, I get 1 over x again. Any questions on those 2 examples? If you need further explanation, let me know. Okay, we're going to a more difficult example. Not hard. So let's say y is equal to the natural log of 6x squared minus 7x. Well, that's you. And what we know is the rule says in order to find dy dx, we put u in the basement.
Professor,
Yes,
I don't know your teaching style, but do you would you give the class an example and you give us a few minutes to do it?
I do that.
Okay.
Yes, I plan to do that.
All right.
You like being able to do that?
I just want to know if because you're basically you are showing us how to do it and everything, but I just wanted to do it by myself to see if I have like a better understanding.
Absolutely. I will do that after this next example. Thank you very much. Okay, so we're now going to multiply by the derivative. So we get 12x minus 7. So therefore dy dx is 12x minus 7. Whoop, forgot my x. When we have time, Diara, I also like to put you in breakout rooms to solve problems. But we haven't gotten to anything really like that yet. Okay, so here's a problem. Y is the log of the sine of x. So I want you to find dy dx. It looks tricky, but it really isn't. Just follow the rule. Anybody want to talk me through it?
I can try.
Okay.
So for dy over dx, would it be 1 over sine x?
Okay, that's right. So we're going to put the sine x in the basement, and then what do we do?
And you times that by the derivative of sine x.
Which would be?
Is it cosecant?
Actually, a derivative. Remember, sine and cosine are partners.
Oh,
So if you, whenever you differentiate or integrate sine, you're going to always go to cosine and opposite. So if I'm differentiating sine, I'm going to get.
what is the other one? Is it? No, that's not it.
What's that?
Oh.
The derivative. I think you were giving me the full answer at the end. You're giving me the whole answer. I just want you to give me derivative of sine right now.
I'm sorry, I can't think off the top of my head what the derivative of sine is.
Okay, it's cosine.
Oh, it is cosine.
It is cosine.
Oh.
So now what you were, I think what you were giving me as an answer, you were saying cotangent.
I actually wasn't giving you the answer. I actually was thinking that was the derivative sign.
Oh, okay. All right. So I thought you had moved forward. Okay, because the cosine over the sine is the cotangent. So now this is just the cosine of x over the sine of x. And that's the cotangent of x. Here's another one. Now for that one, I would probably change the square root of x to x to the 1/2, just so my brain can handle it. So I want you guys to do that problem. Yes. Thank you, Lawrence. Okay, anyone want to take a stab at how to do this one?
Well, for starters, you could do 1 over x to the half.
Okay, so that's exactly right. We're going to do 1 over x to the 1/2. So we're going to put that in the basement. Okay, and then what am I going to do?
And then you're going to multiply that by the derivative of x to the half, which I believe is just 1/2.
So the derivative of x to the half is what?
1/2.
1/2 x to the negative 1/2. I have to use that rule, the power rule. Okay. So I can move the 2 and the x to the 1/2 to the denominator. So I get 1 over 2, and then x to the 1/2 times x to the 1/2 is 2x. Okay, did anybody have a problem with that one? Did you catch that? Y'all are real quiet. Diara,
Yes.
how did you feel about that one?
So right now I'm trying to see where you got 2 from. You said you did something. You said you did something, but I didn't hear what you did with that half.
Okay, all righty. So you do understand that I took this 1/2, x to the 1/2, and put it in the denominator, right?
I got that part, and I got the times half half times x to the negative half. I got that part, but it was the 1 over 2x that I wasn't.
Okay, so basically what I did was I said, this is 1/2. Then I have 1 over x to the 1/2. And I can bring the other x to the 1/2 to the denominator. So now I have a 2 in the denominator. And then x to the 1/2 times x to the 1/2 is just x.
That makes sense.
Okay. All right, so I want to look at some properties of logarithms, because properties of logarithms can make differentiating logarithms easier. Okay. So we have a product rule. So the product rule says if I take the log of two things, A times B, that's the same as the log of A plus the log of B. So if I have the log of 6x squared minus 5 times 2x plus 1, since those two things are multiplied, I can make it the log of the first one plus the log of the second one. Okay, so that's the basic product rule. So why would I do that? Say y is the natural log of 6x squared minus 5 times 2x plus 1. And I want to find dy dx. Well, I'm going to simplify first. So right now we already see that we could go through and find this thing. All right, so we could say, well, that is u of x, and then find u prime of x, and then put it all in and differentiate. What a mess. We're going to simplify this first. Okay, so before we take the derivative, we're going to simplify it. So we're going to write y is the natural log of 6x squared minus 5 plus the natural log of 2x plus 1. So now it's easy to differentiate as opposed to when it was a product. So now dy dx, differentiating the first term, I'm going to put six x squared minus 5 in the basement, and on top of it, I'm going to put its derivative, which is 12x. And then for the other piece, I'm going to put the 2x plus 1 in the basement, and its derivative on top, which is 2. And now I'm done. Nice and easy. Okay, any questions? Suppose y is equal to the log of 2x squared minus 5 times the cosine of x. Find dy dx. So I'll give you a minute to do that. All right, any takers for an answer?
Well, for stars, it would be 4x over 2x squared minus 5.
Okay. So I'm assuming you wrote it as the log of 2x squared minus 5 plus the log of cosine x.
Yes.
Okay, good. And then you did dy dx, and you just told me you got 4x
Mm.
over 2x squared plus 5. And then what else did you get?
Negative sine x over cosine x.
That's correct. Okay, anybody else need further explanation? Okay, let's go on to the quotient rule. So the quotient rule says the log of A divided by B is the natural log of A minus the natural log of B. So say I have the log of 2x minus 31 divided by 2 plus cosine x. Then I'm going to write that as the natural log of 2x minus 31 minus the natural log of 2 plus cosine x. So say y is equal to the natural log, this is a crazy one, 3x cubed minus the sine of x divided by x plus cosine x. All right, find dy dx. So the first thing I want you to do is separate it. Ray Sean, you want to give me an idea how to do it?
Can I try?
Yes. Go
So
ahead, Yara.
first, using the quotient rule from my last calculus class, I'm guessing you do the derivative of the numerator times the denominator, and you subtract that by the numerator times the derivative of the denominator. Does that make sense?
Okay, you're using the quotient rule.
Correct. So in this instance, the derivative of 2x minus 31 times,
Oh, okay, we were actually doing the next one, but that's okay.
I didn't, my bad.
So let me, I just want to say something to you about what you're doing, because what you're doing is making the problem a little bit more difficult than it has to be. So remember, we said that the derivative with respect to x of the log of u of x was to put u of x in the denominator and then multiply by du dx, correct? So now for us, this whole big blob is u. All right, so that means I have to do two things to this. So I would get that dy dx would be 1 over that whole thing. And then I would use the quotient rule, as you stated, to do the other part. Oh boy. So then I would have the derivative of the top would be 9x squared minus cosine x times x plus cosine x minus, and this is very long. So what I want you to do is I want you to simplify it first. So start here and simplify it. So let's simplify first. So we're going to take y, which is the natural log of 3x cubed minus the sine of x divided by x plus cosine x. And we're going to split it up first. So we're going to say y is equal to the log of the numerator, 3x cubed minus the sine of x minus the log of x plus cosine x. So we simplified it first. So now that I simplified it, it's actually easy to take the derivative now, because it's simplified. So since it's simplified, now I can do dy dx. The derivative of this first term is what?
Is it 6x squared? 6x squared plus. Is there more into that, into the numerator?
Yep, it is. It is.
Okay, so I say 6x squared plus cosine.
Okay, the derivative of sine is positive cosine, so we're going to keep the negative.
Okay.
Okay, keep going.
For that denominator, should I imagine there's an imaginary 1 in front of that x?
No, you're making life difficult. We're not even, okay, so let me rewrite it. I'm just going to rewrite y. Okay, so you were focused on giving me the derivative of this piece. So finish it. How do you take the derivative of the log of u? What do you do with u?
Wouldn't it you just oh, no. Oh, would you put 3x cubed minus sine x in the denominator?
That's exactly right.
Okay.
Okay, now you have another one.
So, all right, that one would be. I want to say that x, the derivative of x, because it is a constant, I would just say that's 0. So I would just put.
How many x's are there?
In this case,
How many x's are there?
It's 2.
Nope, right here. How many x's?
Oh yeah, so yeah, it's just 1.
Good. Okay, the derivative is just 1. Okay.
Oh, okay. I thought, okay.
Derivative is 1. Derivative of cosine x.
Negative sign.
Good. And what goes in the denominator?
X plus cosine x.
And the problem is done. Okay. Takes a minute to process, but once you get it, it just flows. Okay, so this is my favorite rule. Because this one can take some ugly problems and make them nice. And this is the power rule. And the power rule says that the log of x to any power, you can bring that power down and make it the log of x. So the log of x to the 4th is simply 4 times the log of x. The log of the square root of x is the log of x to the 1/2 power, which is simply 1/2 the natural log of x. So you can always move the exponent. Okay. All right. So here's an example. Y is equal to the natural log of the cube root, ooh, that's hideous, of 1 minus x to the 4th. Okay, now, there's several ways you can do this problem. All right, so we clearly see that I'm going to rewrite it, is 1 minus x to the 4th to the 1/3 power. That's this. So I just rewrote it. So if I want to find the derivative of y with respect to x, I'm not going to take the derivative of it looking like that. The first thing I'm going to do is simplify y. Okay. So y right now is equal to the natural log of 1 minus x to the 4th to the 1/3 power. So therefore I can write y is 1/3 the natural log of 1 minus x to the 4th. Wow, does that make life so much better? I can take this exponent here and bring it down as a coefficient. I can take this exponent here and bring it down as a coefficient. I can take this exponent here and bring it down as a coefficient. So now when I go to do dy dx, the 1/3 doesn't matter because it's a coefficient. Now I have the log of 1 minus x to the 4th. So I'm going to take that 1 minus x to the 4th and put it in the basement. Then I have to multiply by its derivative, which is 4x cubed. So now I get that dy dx is 4/3 4x cubed divided by 3 times 1 minus x to the 4th. Okay, question?
Yes, I got a question.
Yes, Ayana?
Yeah, where did the 1/3 go?
The 3, okay, so the 3 is actually in the denominator.
Mm-hmm.
So it's here.
The 4/3.
Here's the
Okay.
3 in the denominator. Here's the 3.
Okay.
No
Thank you.
problem. Just want to make sure that's clear. Find dy dx if y is equal to the natural log of 6x minus 2x cubed to the 5th power. How do I go about simplifying y? Before I differentiate, I always want it to be in the easiest form possible.
That would be, in this case, 5 ln in parentheses 6x minus 2x3.
Okay, so bring down the 5, the natural log of 6x minus 2x cubed. Now that's simplified. That's nice. I can work with that. Because now I don't have to worry about the 5. That's the coefficient. And I'm just integrating something like some u to the 5th power. So what would the derivative be? Xavier. You're still on mute.
Wait, can you say that again?
Okay, so we started off with y is equal to the natural log of the whole quantity 6x minus 2x cubed to the 5th power. So then we simplified it. So we brought the 5 down. Remember, we simplify it if we can. We brought this 5. Well, yeah, that 5 comes down to here. So it got simplified. So now I need to take the derivative. So I only really have to do this piece because the 5 I'm just going to multiply in the end. So this is like the log of u. So how do you take the derivative of that one term? So let's go back. Okay, Xavier, we're going to go back. Okay, so when you're taking, whoop, gotta go back. There it is. Okay. So when you're taking the derivative of the log of a function, you put the function in the denominator, and then you put its derivative on top.
Mm-hmm.
You see that?
Yeah.
Okay. All right.
Oh,
So now what's the function u that I'm working with? What is u?
Wait, can you scroll down to the u would be 6x minus 2x to the third?
Right. Okay. So when you go to take the derivative,
Uh, so the
I'm already going to have a 5 there. So now what do I do?
well, you put 6 minus 6x squared over 6x minus 2x to the cube with 5 to the left.
Divided by 6x minus 2x cubed. Looks good to me. Okay, does that reinforce your understanding a little bit?
Yeah, I have a question, Professor.
Okay.
So we have an exponent in this situation. So why wouldn't it be like the exponent not change to 4? Like, you know how you got to subtract 1? Why would we not subtract 1 with the exponent?
Why would the exponent not change to 4?
But do you know what I'm saying? Like, you drop the 5, why would it not be 5x to the 4th? You know what I'm saying? I'm just asking, really.
Okay. All right. That is such a good question. Okay. Because we are not using, okay. Woo. Okay. All right. So here's the difference. All right. So let's clear up this confusion. Okay. So here's y is equal to the natural log of 6x minus 2x cubed to the 5th power, right? So now one way I could actually do this problem is I could say, so this is going to be method 1. I could say that u is equal to 6x minus 2x cubed to the 5th power. And then y is equal to the natural log of u. Does everybody see that? So this whole thing is u. So now if I use the rule that dy dx is 1 over u times du dx in the numerator, then I would put u in the denominator as 6x minus 2x cubed to the 5th power. That's u in the denominator. And I would multiply by its derivative, which is going to be 5 times 6x minus 2x cubed to the 4th power. Chain rule says take the derivative of what's inside, which is 6 minus 6x squared. Okay, so here, this is u, and this is du dx. But now when I simplify this, I get 5. I have this to the 4th, and then I have the thing to the 5th power. So that puts it into the denominator to the 1st power. And then I still have 6 minus 6x squared in the top. Okay, so what I did here was I used the definition that the derivative of y with derivative of of the log of u is 1 over u du dx. Okay. Is everybody clear on that part? Okay, Xavier, are you clear on that? What I did was I took and threw u, all of u to the denominator, the whole u, just as it was. And then I used the chain rule to differentiate u in the numerator. And then I simplified the expression. And the only thing I used was the definition of the derivative of the log of u. That's the first method. Now, the second method is to simplify y first. So in method 2, we simplify y first. Okay, so in the second method, we simplify first. So we say then that y, by the logarithmic powers, says that y becomes 5 times the natural log of 6x minus 2x cubed. Okay, that's because if y, that's because we can take the log of anything to the 5th power and make it 5 times the log of that thing by the power rule. The log of p to the 5th becomes 5 times the log of p. So if I simplify it first, then I don't have then there's no derivative of it to the 5th power. So now that it's simplified, I can say now that when I take dy dx, the 5 is already there, but this time I have a different u. I only have this. I don't have it to the 5th power because I simplified it first. So when I simplified it first, now I put 6x minus 2x squared cubed in the denominator, and I put its derivative in the numerator, 6 minus 6x squared. And I get the same answer. So for this one, I used the power property of logs first. Okay? Because if this thing inside here is really hideous, like when we had the quotient rule, then I would have to not only put that thing in the denominator, I would have to do a hideous quotient rule. I'm trying to avoid that and make my life easier. So I simplify the problem before I take the derivative. So it's important to note that the domain, I'm going to say something about what we just did. Domain of the log of x is equal to the set of all x that are real numbers such that x is greater than 0. And then the range of the natural log of x is just the whole real, it's just R, all real numbers. Okay. So let's recap. Y equals the log of two different functions multiplied. Then I'm going to simplify it first to make it the log of f of x plus the log of g of x. I'm going to simplify it first. Oh, I don't want that derivative there. And then I'll take the derivative, which will say put the f of x in the denominator and put its derivative in the numerator. This one will take and put the function in a denominator and its derivative in the numerator. So that is so much easier than trying to do a long problem. Okay, so if I have y is equal to the log and I have two functions over top of each other, I'm gonna simplify it first. The log of f of x minus the log of g of x. And then when I take the derivative, I'm going to put f of x in the denominator and its derivative up top. And then I can do the same to g. G of x in the denominator and its derivative. Whoop. Okay. And then the third one was the power rule. Y is equal to the log of some function u of x to a power. The first thing I'm going to do is simplify it. I'm going to bring that power down and make it the log of u of x. So then when I go to find its derivative, that power just sits there nicely. And I do like before. I put u of x in the denominator and I put u prime of x up top. So that's how I do all of those.
Can you move the screen a little up?
Like that?
Yes, that's fine.
Okay. Okay. All right, the last thing we're going to do with the logarithms today is logarithmic differentiation. And this can be hideous, but you got to know it. And
Sorry, Professor. Could you go up one for like 2 seconds?
no problem.
All right. Thank you. All right, you're good.
Okay. Okay, so logarithmic differentiation, I like it a lot. It's a great way to take a derivative of a hideous, hideous problem. Okay, so let's say we have something like y is equal to the sine squared of x divided by the cube root of x cubed plus 1 to the 4th power. And we want to find dy dx. Okay, now in order to find dy dx, I have to use the quotient rule. Oh, I have to use the chain rule twice. And then I got to simplify it. And by the time I do all that, I could have made a plethora of errors. Okay, the derivative of the numerator, I have to do 2 sine x times cosine of x. I got to rewrite the denominator as x cubed plus 1 to the 4 thirds. And then I got to do a chain rule on that and then simplify. Pretty hideous. So what we're going to do is we're going to do what we call logarithmic differentiation. And here is the method. The first thing is we start with y is some function of x. So let's take the log of both sides. Okay. Then we're going to differentiate both sides. So when I differentiate the left-hand side, I'm going to get 1 over y dy dx. And when I differentiate the right-hand side, I get d dx of the natural log of f of x. And notice, what was I trying to solve for? I was trying to solve for dy dx. So now if I just multiply by y, dy dx pops right out. So I get dy dx says multiply y by the derivative with respect to x of the natural log of f of x. Okay. So that's the technique. We're going to do everything we possibly can to simplify this thing first. Okay. So we said that y is equal to the sine squared of x.
So you had put the y on the right, correct?
Yep, I multiply both sides by y. Over the cube root of x cubed plus 1 to the 4th power. Okay, I'm going to rewrite that first as the sine squared of x over, I'm going to use my fractional exponents and write that as x cubed plus 1 to the 4 thirds power. Okay, so let's start there. Now we could do the chain rule on the quotient rule and chain rule, but it's pretty nasty. So what I'm going to do is take the log of y. So let's remember what y is. Let's take the log of y. So it's the log of the sine squared of x divided by x cubed plus 1 to the 4 thirds power. And what can I do with that? I can use a bunch of those rules we just learned. So now the log of y is the log of the sine squared of x, which is the sine of x squared, minus the log of x cubed plus 1 to the 4/3 power. Well, that's looking better already, because now I can do the log of y. I can bring the 2 down and make it the log of the sine of x. And I can bring the 4/3 down and make it the log of x cubed plus 1. Now that right there is so much nicer than what I started with. Okay, so now let's plow through with the derivative. On the left-hand side, I'm taking the derivative of the log of y of x. Well, that says the y in the denominator and then multiply by dy dx. That's what the derivative says. Take the derivative of the right-hand side. I get 2. I'm going to get sine x in the denominator. And I'm going to get cosine x in the numerator. I'm going to get 4/3. I'm going to get x cubed plus 1 in the denominator and 3x squared in the numerator. And guess what? I'm done. The only thing I have left to do is to multiply by y. So I get dy dx is going to be y times all of this. So I get 2 times the cotangent of x minus 4x squared, because the 3's are going to divide out, over x cubed plus 1. So my answer is dy dx. I got to go back and remember what y was. Where's y? Where's y? There it is. It is the sine squared over x cubed plus 1 to the 4/3 power.
Hey, Professor. So with the 4/3 times 3x squared over x third plus 1. So you basically simplified it more. So I'm guessing, did the 3's cancel out?
Those 3's divided out just like that.
All right.
And then in the denominator, I have x cubed plus 1 to the 4/3 power. And that's all multiplied by 2, the cotangent of x, minus 4x squared divided by x cubed plus 1. Now here's a place where I wish I could, let me see if I can shrink that. Yeah, I can shrink that just a bit. I wish that I could give you time to work on a problem, but we're kind of out of time.